A long, long time ago, in a physics lab far, far away, 5 upcoming young man Padawans banded together to make the nerdiest physics hologram ever. This is where their journey begins. Ba 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 ba.
As Maddie and Jake march, they travel 5.0 meters in 4.01 seconds.
Righto!
Using the equation velocity equals delta x over delta t, we find their constant velocity to be 1.25 meters per second.
Casey, Maddie, and Jake all march to the same dot, making them precise but not accurate.
Aha! In this example, Maddie, Jake, and Casey all march to the same dot, making them precise, as well as marching to the correct dot where the clarinet is placed, making them accurate.
They didn't march to the clarinet, or to any other dot for that matter, making them neither accurate nor precise.
Casey, Maddie, and Jake? They just did it plain wrong!
This is an example of relative motion. To Jake's point of view, Tina is moving twice the speed of Casey. To Tina, Casey is moving half as fast, and to Casey, Tina is moving twice as fast.
For the box drill, Jake marches 5 meters east, 5 meters south, 5 meters west, and 5 meters north. When finding and combining the delta x and delta y, the total displacement is 0 meters. Tina throws her clarinet at the horizontal with no upward angle, making it a horizontal projectile.
Yay. Tina is holding her clarinet at 1.9473 meters off the marching field. When she drops it, it takes 0.60 seconds to fall using the equation final velocity equals 2 times delta y divided by delta t. We can find the clarinet's free fall velocity to be 2.34 meters per second. Hop, do it!
Acceleration is the rate of change in velocity. Maddie and Casey speed up, resulting in a change in velocity in the negative direction. This example gives them a negative acceleration.
When you add Maddie, vector 1, and Brian, vector 2, you get a resultant.
This resultant is added from the tip of Maddie's vector to the tail of Brian's vector. Newton's first law of motion states that an object at rest stays at rest, and an object in motion continues at a constant velocity unless the object experiences net external force. In this example, Brian is the object at rest and is hit by Maddie, making him fly forward. He secondly is an object in motion after being hit, but hits the pole, disrupting his constant velocity.
Due to the friction between Casey's tires and the ground, she doesn't hit Maddie!
In order to maintain circular motion, such as riding a unicycle, you have a centripetal force. In this case, the mass of the tire multiplied by tangential velocity squared, divided by the radius of the tire, would calculate the centripetal force of the wheel. Any point rotating around an axis has a tangential speed, and therefore, if it were to break off from the rotation, it would continue in a tangent to the circular motion. Tina is the axis that Brian rotates around as a point. When he breaks off, he continues running straight forward as a tangent. The law of inertia states objects don't want to change how fast they're going. They will only speed up or slow down if something pushes or pulls them. The heavier something is, the more inertia it has. The tablecloth pulls on the cookie cutters when we move it. If the cookie cutters have enough inertia and we pull the tablecloth fast enough, they should remain on the table. Obviously, the cookie cutters didn't have enough inertia and Jake didn't pull the tablecloth fast enough. When Maddie is confronted with the locked band hall door, she pulls on the door handle to open it. The applied force from Maddie on the door makes an action-reaction pair so that the force of the door on Maddie is equal, therefore making it
equilibrium.